I think you're sure.
Yes. Oh, so finish page 36 for science for 7th grade. 8th grade is Genius Hour tomorrow. And there's nothing in geo except for current events. Okay, so bit of review. What kind of graph is this?
Speed.
Graph. What kind of graph is this?
A speed.
A speed graph. And you said time versus distance. Yeah, time versus distance. It is known as a speed graph, even though we don't plot the numbers of the speed given. So what does that mean? Yes, ma'am.
That you plot distance and time.
You plot distance and time, okay? So you battleship it, right? You can go over here and you can go up here and you can see in 9 seconds they went 10 meters, right? So the slope of that line, what is the slope of that line?
The angle.
The slope of the line, right, it's at an angle. It represents what?
Speed.
How fast?
Speed. How fast something is going. That is the slope. And when you get further along in your math class, you'll learn rise over run. Okay? Rise is here. Run is here. That is speed. So the slope of the line is speed. This is a speed graph. And the purpose of a graph like this is to do what? What does this graph tell us?
See who goes faster.
See who goes faster. Or who goes slower. Right? So it compares speed. All right? So when we put the two lines together, we can definitely tell who's fastest and who's slowest. So here, who is fastest? And how can you tell that was really fast?
Because her line is steeper than Eddie.
She's steeper.
The line is steeper. Great. Okay. Now we're going to get a little bit more complex. Okay? A little bit more complicated. There are more graphs that help us represent motion rather than just a plain old speed graph. This is relatively simple. So ready for more complex?
Yeah. No.
Yes, absolutely.
I'll try.
Okay, good. So most of the motion events we've been looking at are simple. We investigated cars rolling down straight ramps and races between you guys at a constant speed. We looked at boats at a constant speed, trucks at a constant speed, pogo sticks, remember that? They're going at one constant speed, steady speeds. But not all motion events are simple. Some are pretty involved. So you could have objects that travel at different speeds, that stop in different places, and even are going in different directions. Gets pretty complicated from there, right? So today we're going to start to look at more complex motion events. So take a look at your story there. Okay, and let's read this scenario together. So it says, Sue Ellen and Josie went to the show Saturday. Josie's mom drove them the 5 kilometers to the show. The ride took 10 minutes. The movie, The Lizard Queen, wow, lasted 1 hour and 20 minutes. The girls then jogged home. It took them 40 minutes. 40 minutes to go 5 kilometers, that's pretty good. That's not bad. Okay, so what we're going to do is we're going to make a position graph that represents the girls' outing. But first, we're going to put it into a chart so we can kind of really study the legs. All right, so what information do we know? Yes, ma'am?
That Josie's mom drove them 5 kilometers to the show.
Okay, so it is
And it
5
took 10
kilometers.
minutes.
And that took 10 minutes. Kayla?
The movie lasted for 1 hour and 20 minutes.
1 hour and 20 minutes. Good.
Their 5 kilometer jog back took 40 minutes.
And the 5 kilometer jog back took them 40 minutes. Good. Okay, do we need to know anything else? Pretty good, huh? Okay, so let's start looking at all of these columns. Okay. You notice that here the motion is not continuous. There's times during the trip when the travelers are not moving, right? What do you suppose their speed is at those times?
0.
Zero what?
Kilometers.
per minutes.
Kilometers per minute. Let's look at our chart and see what we're dealing with. Yeah, we are in minutes, so we're not converting to hours. That'll make life easy, right? Okay. Somewhere on this paper, I need you to define a word. Okay, and the word is legs. So go ahead and write the word legs.
Aren't those the things that you run with?
Nope, not here. So we're gonna write legs. We're gonna define it. A series of complex motion events. 4x4 is my favorite race in track. Who ran that last night?
They're all, I think most of them are in
Yeah, who ran it?
Aaron, Trista, Bree, and Ella.
Okay. All right. So who ran the first leg?
No, Trista. No, Brianna. Brianna and Trista.
No, Trista ran the first
Trista,
one.
yeah, Trista ran the first leg. Trista ran the first leg. And who was the anchor leg? Aaron.
No,
Anna was like third. Aaron was the anchor, Anna was third, then it was Ella, and then, yeah, so Trista
was
Ella,
first.
Anna, Aaron.
Gosh, that's complicated.
I
All
thought
right. So
Bree wasn't in it.
we have
complex
a series of complex motion events. We've got 4 different competitors, probably running at different speeds, but they all ran the same distance. And what was their direction?
Same way.
Around the track, right? So they started in position X, but that they ended back up in position X, correct? Does that get tricky? They're not just running in a straight line like the 4x1. Who ran the 4x1? You did, and you did.
And then Brianna
And Grace.
us 3 and Bree and Grace.
Do you have 2 teams?
No.
Oh, it's just you guys and Grace.
Yeah.
Gotcha. Okay, so that makes sense. I forget. That's a back and forth, right?
No.
No, it's everyone runs 100 meters.
So you do go around the track, so you end up in the same position as well, right?
Oh, no, that's bad.
Shuttle hurdle?
Shuttle hurdle. That's right. Who ran that last night?
We didn't have a shuttle hurdle.
You didn't? Okay. That's cool. All right. So can you see how legs of a race could be considered a series of simple motion events? Yeah. Well, they are. How many legs does this trip have?
3.
4.
Because they're going there and then they stop and they go back.
All right. Discuss with your group. Come up with a number. Hold your fingers up when you're done.
Okay, so what?
So because they go to the movie, so that's 1. And then,
Well,
then they go, it's only 2.
well, okay, so they get. Well, they go from the house to the car. From the car to the.
They go from the house to the car to the car to the movie, out of the car into the movie, and then back. It's
Yeah,
great.
well,
It should be great because the movie.
I don't know, 3.
Okay. I'm seeing 3s and a 2. So 2. Explain yourselves.
Well, they went there, and they came back.
They went there and they came back. Okay, and you.
We said 3 because they're doing something when they're watching a movie. It's not like they're just stopping and then going again. They're going there for a purpose, taking an hour and 20 minutes to do it.
Okay, so it takes time to stay there, right? So that time lapse, you're considering it a leg. Okay, so if we look at our image, right? If this is where they left from, okay, if this is their home, they drove 5 kilometers in this direction. Notice it's got a positive sign. That comes into play too. So it's a direction. We're going to the movie theater, and it takes a certain amount of time, 10 minutes. Then they're here for how long?
An hour and 20 minutes.
An hour and 20 minutes, and then they come back in the negative direction, and how long does it take them to come back?
40 minutes.
40 minutes. Okay, so yeah, those could be our 3 legs. All right? Could you determine how fast the girls travel during each leg? Carter, you're saying yes. Can you explain?
Then you can just take since it's 10 minutes, you can take 10 minutes divided by 5 kilometers, which would be 0.5 kilometers per minute. Then when they're there, you take 0 kilometers divided by 50 minutes, which would be 0 kilometers per minute. And then you take 40 minutes divided by 5 kilometers, and that would be
We got a distance, we got a time, right? So we could calculate speed for all 3 legs, right? We happen to know the speed while they're at the movie theater, right? Piece of cake. We have a certain amount of time, and we have a certain distance. 0. They don't go anywhere. Okay, so let's look at our columns here. Okay, column 1 is labeled leg. All right, so we've got 4 spaces there. However, you said there were 3 legs. So what's leg 0?
They're at their home.
When they're at their home, right? So leg 1 is to the movie theater. Leg 2 is staying there. Leg 3 is coming back. You could go ahead and write 1, 2, 3 underneath 0. That's fine. All right. The rest of this will be filled out with your partners. So hold your pencils. Remember, we're not just trying to accomplish getting it done. I want you to learn from it, okay? So column 2 is labeled time at the end of the day.
Leg.
Oh, time at the end of the leg, sorry. So go ahead and put a T at the top of it. Oh, it already has T. I'm sorry, never mind. In the future, like, this kind of gives you a description, but as we get more complicated, you're just going to be using symbols. So I'm going to kind of decode what these symbols mean. So this column will be a T. All right? And so what you want to think is, this is cumulative. Can you tell me what cumulative means?
You can have more than one. Like it
No.
adds up.
It adds up gradually, right? So it goes, if the first leg takes 60 seconds and the next leg takes 60 seconds, the time would be 120. It's like you start that stopwatch and you just continue it. Does that make sense? And you don't hit lap, right? You just accumulate the time. So at the end of leg 1, where is that stopwatch at? At the end of leg 2, where is the stopwatch at? At the end of leg 3, where is the stopwatch at? So when you're talking about 4x1 or 4x4 or shuttle hurdle, it is, like the time when your first runner finishes, the time when your second runner finishes combined, your third runner combined with the first and the second, and then your finish time, it's cumulative. So that's a lowercase t. Okay? The third column, position at the end of the leg. So its symbol is an X. Okay? And this is straight up, where are you? X marks the spot. Okay? So if my position is here, okay, and this could be my start, it could be 0. And if I walk 5 feet this way, then my position is at 5 feet. And then if I walk back maybe 2.5 feet, then my position is 2.5 feet, because half of 5 is 2.5, right? And then if I go all the way back to the beginning, where's my position? 0. So when you're talking about legs of a 4x1, you have your start line, you have your starter, okay? And then your position goes around the track, but it ends back up at 0. Weird, huh? Your shuttle hurdle relay is really interesting, because if it starts at 0, right, and then it goes down the track to 100 meters, right? They finish at 100 meters, then the next person goes back to 0. Then the next person goes to 100, and then the fourth leg ends up at 0 again. Cool? So position X is where are you? Where are you standing? It's not cumulative. It's where are you? Okay? Column 4 is time interval during the leg. That's a delta t. What does delta t mean?
Change in
A change in time. How is this different than the second column, time at the end of the leg t? Go ahead. What do you think? Because it's the time what? You don't know. Kayla?
Would it be the first one would be the time, like all the time it took, so but the other one would be the time, well the longest divide, or minus the first one.
So it's a change in time?
Yeah.
Not necessarily from the first one.
Well, like the beginning time, or the last time, the longest time minus the shortest.
Sometimes. Depends which one you're talking about. Talk to me in terms of legs.
In this case, the third leg minus the first.
Nope. Not quite. So delta t is the time interval during the leg. So when their leg started to when their leg finished, just their leg. So your second leg of the 4x4, or you ran the 4x1? Yeah. So the second leg of the 4x1, who ran that?
Emily.
What was your time, Emily? What? You don't know? Okay, we'll just go with,
I think it was like 13. No, it's 15 something.
beautiful. So we'll go with 14. Yeah, so Emily ran it in 14 seconds. Let's say that, right? That's your leg, that's your delta t. Just your time, okay? Not the cumulative time. So our second column, time at the end of the leg t, that's like your whole team's. And it's continuous, and you don't stop the clock. The time interval during the leg, those are your laps. That's when you push lap on the timer. So you would be 14, and she would be 20. Just kidding. Okay? And she might be like 13, and then Grace might be 16. Just that time interval. The delta t is the change in time just for the leg. Okay? Now let's talk about displacement during the leg. Do you notice that symbol, delta x? Change in, what does X stand for? Position, a change in position. Displacement during the leg. All right, so displacement is going to be a vocab word. You want to write that maybe above it, off to the side somewhere on this paper. So here's the symbol, delta x. Okay, and here's the tricky part. It is an equation, xf minus xi. Where did they start initially? And where are they going? I should be writing this down. I'm still writing. All right, the tricky part with displacement is that it can be positive or it can be negative. So where that leg starts to where that leg ends is your xi and xf. So if it starts at 0 and it ends at 10, it's going to be positive. Well, let's say it ends back at 0. So like our third leg, for example, ends back at 0. If x is 0 and xi is 10, like where they started from is a position of 10, and we could say this is kilometers. What is 0 minus 10? It's going to be a negative 10. So you will find some negative numbers here. Okay? And then finally, total distance of travel. This is cumulative. This is a running tally. So your 4x1 team, what's the total distance traveled? It's a 400. What's the total distance of your 4x4?
1,600.
A mile, 1,600 kilometers, or 1,600 meters, sorry. 1.6 kilometers. Okay? Which is, yeah, close to a mile.
What's the time at the end of the leg?
What's that?
What's the other one that's cumulative?
Yeah, time at the end of the leg, T, is cumulative. All right, so I'm gonna have you fill in the chart with your partners. Okay, I'll come around and check to see how you're doing. Ready to go. So now this is how you guys are gonna discuss. Do we have most of you in there? Yep. Okay. Yeah. Okay. So fill it out together. Discuss.
Do we start here?
You can start. You can start like I would suggest like filling in the columns that way, the rows.
So like going each row.
Go each row. So look at one leg at a time.
Okay, so the first one would just be 0 every time.
This one would be the 10 plus
Let's start at 1.
Because
it's easy. Okay, so time at the end of the leg.
So
10 minutes.
displacement during the leg, delta x is like your change in position. So they go from everywhere.
And then
And what
position at the end of the leg.
let's say you're positive and
5 kilometers.
so the first leg, right? So it takes them 10 minutes. They go
10 minutes.
As in 0 to 10.
They go 5
Or, so it would be negative 10.
0 to 5.
Because it's 0 minus 10. Because you're going from 0 to 10.
No, that's not this one. That's the distance. It's the time. So it would be 10 minutes. Because
Oh, that is a change.
this is the it's the change.
Oh wait, it would. So it would be 10 minus 0. So then you have 10.
But the next one is the negative 10. Right?
Yeah, because it's saying it's going from 0 to 10 and then 0 minus 10.
So xi would be 5. And x
Total distance of travel.
5 minus 5 is
That's 5 because they've only gone 5. Okay, now for the cumulative ones, we have to add it on to 5.
Oh, so the cumulative thing would be just you add these two to
Yeah,
this.
you add 10 on. Like, so it starts at 10. You keep adding on 10.
So like for the distance traveled for the next one it would be 0. So you just add 0 to 5, which would be 5. Okay.
Yeah. For the cumulative. Okay, so then the movie lasted an hour and 10 minutes. Time at the end of the leg.
So 1 hour 30, 1.5 hours.
Yeah, hold on, we need to add.
Yeah,
It'd be 60 minutes.
well 1
So
hour.
90 minutes. Right?
Well 1 hour 60. Yeah, 90 minutes.
Because it's a minute.
And then the position at the end of the leg would still be 5 kilometers, right?
No, it'd be 0 because it's not cumulative. It's at the end of that leg.
Yeah, at the end of that leg, they'd be.
At 0 because it didn't move. Right?
I don't know.
This is right. So for the position at the end of the leg, we're talking about leg 2.
Like for
When
this
they're
one.
at the movie, they didn't move.
So it'd be 0.
So
Or would you add?
say where are they? Like x marks the spot,
They're at 0 because they
Well,
didn't move.
wouldn't they be at 5?
but
though?
this is 0.
So
X
So they'd
is
still be
0
at 5
here.
then.
They'd still be at 5.
This is 0.
Yep.
time interval during the leg, wouldn't that be the 190 minutes?
Yeah.
Are you on displacement for leg 1? Okay, so
And then-
displacement for leg 1, you have xf minus xi.
10
So
minus
where
9.
are they at the start
So
of
80
this leg?
minutes.
So they're at 0.
Negative. Would it be
Okay.
negative 80 or
And then where are they at the end of the leg, xf? They're at 5. So you do 5 minus 0.
Oh,
You're going to get 5. Yep. So does that make sense? Is that the change in position? They go from 0 to 5
wait,
and that's
why
5.
right here is a negative 10?
So you're good.
What is that, right?
Yeah,
Yeah, but we did the.
Yep.
Well, the negatives, right? But wouldn't it
Take
just be
10
negative
minutes
5
to get
and not
there.
that?
The next one.
Yep, you're
No,
doing
this
good.
one.
Looks like you're ready for leg
I don't
2.
know.
Yeah.
And for this one, the change in position would be is still well 0.
The distance, displacement during, so
Would it be 0 because they didn't change position at all during that leg?
it'd still be negative 5. They're still at negative 5.
But this is during the leg, so that would have been this one. Like
It's not cumulative.
so, this is saying the change.
Yeah, but there is no
I
change,
know.
so they're still at negative 5.
No, since there is no change, it'd
This
be
is
0.
0.
Yeah,
This is 0.
but that's saying it's not talking about where they're at. It's talking about the place. So it's talking about the change.
They're still at negative 5.
Yeah, so they'd move 0, so the change would be 0.
They'd still be at 5.
Yeah.
Okay. 90 minutes. 130 minutes.
90 plus 40. 90, 130. Wait, which is 130? Yeah.
Position at the end of the leg.
So would they be at 0 again?
Yeah, they're at 0. Right?
Well, this is a 10
No,
minute.
but it's during
this
the
is
leg.
during, so
Yeah,
it would be.
So wouldn't it be?
So wouldn't this one be 80?
Yeah.
And then the last one be
40.
Yeah.
Because it's during that leg. It's not.
Yeah.
It's
So
not accumulative. So, but this last one's no. This one.
this one would be 5 again. The displacement would be either it would be 0 or 5. No,
Yeah,
0 would be
because
5.
5 minus 0. This is just 5. It's not.
Yeah.
And then 10.
Wait, why would it be 10? Oh wait, yeah. Do we graph it first or? True.
Is this what you did? Oh, I didn't add my zeros. 10. Oh, we got 90 here because it's a cumulative. It adds up. So we got 90. Not 80.
Oh yeah.
But then 80 is the next one.
Yeah.
And then this one's 130.
Yeah, because you had
550. Oh, we got negative 5 here and 5 here.
switch.
And then we have Kayla. I told you it was 0.
Yeah, because 5 minus 5. Yeah. I told you it was. I don't know where I told you something.
travel. They didn't go.
No, but it's a cumulative. No.
It is.
Yeah, it's a cumulative because they're still at 5. I wrote cumulative on the ones that are cumulative.
I have my paper back.
9 plus 8. So are we right?
Probably not, but you know. It's cool. Why is there a cat card?
Just like that.
Really?
Which one? What other ones?
The first one and the last one.
Okay. 0, 5. So Is that one
Yes.
5? Yeah. And then the last one's 10.
Don't ever ask me.
Yeah.
You know when I get to I always
Oh, she told us that this one was 5.
So the first one's 5 and the second one's negative?
The last one.
That's what I meant. The second 5.
So this one's the last one?
I don't know.
How do you spell cumulative?
It's cumulative.
How do you spell that?
I put a C.
Where's your switch?
I was hot earlier. Can I pause this?
Yeah.